Physics, Part 163. A. Calculate the value of the resistance R. B. State and explain what happens to the voltage at terminal A when an additional 1.0 omega resistor is connected between terminals B and C in parallel with the 5.0 omega resistor. No calculations are required. Alternating current. At the end of this section, you should be able to represent a sinusoidally alternating current and voltage by an equation of the form x is equal to x0 sine theta. You should be able to show an understanding of and use of the terms period, frequency, peak value, root mean square value as applied to the alternating current or voltage. You should be able to deduce that the mean power in a resistive load is half the maximum power of the sinusoidal alternating current. You should be able to distinguish between RMS and peak values and recall and solve the problems using the relationship LRMS is equal to L0 into LV divided by 2 under root. For the sinusoidal case, you should be able to distinguish graphically between half wave and full wave rectification. You should be able to explain the use of a single diode for the half wave rectification of an alternating current. You should be able to explain the use of 4 diodes, the bridge rectifier for the full wave rectification of an alternating current, and you should be able to analyze the effect of a single capacitor in smoothing, including the effect of the value of capacitance in relation to the load resistance. Up to this point, we have dealt with the systems in which battery is connected to a circuit and the current flows steadily in one direction. You will know this sort of current as a direct current, abbreviated to DC. However, the domestic electricity supply produced by generators at a power station is one which uses alternating current, AC. An alternating current or voltage reserves its direction regularly. It reverses its direction regularly. An alternating current or voltage reverses its direction regularly and is usually sinusoidal. We can represent the current and voltage by equation I is equal to I0 sine watt, V is equal to V0 sine watt. The time t taken for one complete cycle of AC is the period of the current. T is equal to 2 pi over watt. The reciprocal period of the frequency F, that is, F is equal to I over T into F is equal to watt over 2 pi. The frequency is the number of complete cycles of the supply in 1 second. The unit of frequency is Hertz, Hz. The peak value of the current voltage is I0 or V0. The amplitude of the oscillating current or voltage. Sometimes the term peak-to-peak value is used. This means 2 over 0 or 2V0. It's 2L0 or 2V0. It is clear from our figure that the average value of an alternating current is 0. However, this does not mean that when AC source is connected to a resistor, no power is generated no power is generated in resistor.